Hello everyone, I am Mr. Ashok Kumar from AKLC and VTUprojects.com. In this video I am going to explain to you about the project building a version control system in Hadoop HDFS. So these are the things that I am going to explain to you in this video. So coming to the quick facts or the summary of your project. So the first thing is area or the domain of our project. The domain of our project comes under big data. So the base reference tells that where we got the idea from. So we got this idea from an IEEE 2018 paper. So it's the recent publication of IEEE. So we are referencing our idea from that particular paper and we are implementing our own solution. So and which algorithm or which technology we are going to use? So we are going to use a technology called CVCS. So the expansion for CVCS is Centralized Version Control System. So you are going to understand more about this algorithm in the project related classes. So you just have to mention which algorithm or the technology you are going to use in this project. And which framework and the platform we are using in our project. We are going to use the Java framework on Hadoop platform. Okay, so that means we are going to develop the entire project using Java and related technologies, and it will be running on an Hadoop machine. So and the number of lines of code in this particular project will be around 4,000 lines of code. So approximately around 4,000 lines of code. So on an average, and finally a project will be completed within 1000 or sometimes 1500 lines of code. But in this particular project we are going to write around 4000 lines of code because the number of modules and the features we are going to implement. So these many lines of code are required, and each lines of code will be easier to understand. And the percentage of the database used will be lesser than 7% of the database. So the reason why I am putting out this point is because many universities will say you should not use more than 20% of the database. So we are well within the safer side because we are just using lesser than 7% of the database. So coming to the prerequisites, so before actually understanding what our project will do, you need to have a basic idea about Hadoop, big data, HDFS and the things like that. So if you are already aware of these technologies, so please skip the next 15 minutes. So because in the next 15 minutes I am going to explain to you some basics of big data and Hadoop related technologies. So here I am going to quickly give you a brief introduction to what big data is and what Hadoop is. So firstly, to speak something about big data, as the name itself will indicate, big data is something to deal with the huge amount of data. Okay, so I am going to take an example. So one research says that from the start of the time where we started to collect the digital data, say for example from 1940 till 2010. Okay, one research says we have collected around 15% of data. Okay, so whereas from the past 5 to 6 to 7 years, from 2010 to current, okay, the research says we have collected around 85% of data. Okay, so if you see the result of this particular research, right, it is clearly understandable that the size of data is getting huge year by year. Okay, so to speak about the sources, so from where actually this huge amount of data comes from. Okay, so you can think about the social media like Facebook. Okay, how many users have their Facebook account? You upload a photo, that's a data. You go and like someone else's status, that's a data. You comment on some post, that's a data. So social media, say for example the Facebook itself will provide, will generate 1 terabytes of data every single day as per the research. Okay, so other sources contains e-commerce, online shopping, and and also the airplane. Okay, if you have heard about the airplane black box technology, right? So that airplane black box is something that will have the information about whatever comes in its way, like the weather information, the temperature, the humidity, whatever it is. So it just starts collecting the data whenever a flight is running from a source to destination. Okay, it has been estimated that a single flight that runs for say Bangalore to Pune, okay, will produce the same amount of data as that of Facebook's 1 day data. Okay, So and everything is getting digitalized so far. So for example, health data, a single DNA report also will contain very huge amount of data. Okay, so these are some of the examples where the data are coming from. Okay, so day by day, I mean the year by year, the amount of data we are collecting is increasing like anything. Okay, so but you have to understand, the problem is not with collection of data. We have pretty much storage devices. There's no limit in storing the huge amount of data. Okay, but the problem is in processing the collected data. Okay, it has been said that we have simply collected huge amount of data, but there is no efficient way for processing the data. Okay, so this is what we call it as big data problem. Okay, so I'll just repeat. So the big data problem is not with respect to the collection of data. It is with respect to processing the collected data. Okay, so for processing this huge amount of data, right, there are many solutions. Okay, like NoSQL database, graph database, something like that. Okay, Hadoop is one such solution for processing this huge amount of data. Okay, so this is something that you people have to know about what big data and what big data problem is all about. Okay, so now speaking about Hadoop, right, as I told you, Hadoop is one such solution for processing huge amount of data. Okay, so before Hadoop, what was what you people were used for processing the data? So for example, you have used MySQL database, Oracle database, something like that. Okay, so but Oracle database and MySQL database, they are grouped into a kind of DBMS called relational database. Okay, so this relational database management systems are not efficient for processing huge amount of data. Okay, so I'll tell you the reason why. Say for example, assume that you have to store a college student information. So you are going to create a student table. Okay, you want to store the department information. You are going to create a department table. You want to store the project information. You are going to create project table, and something like that. Okay, so in student, right, you will have USN, you will have name and department number as the columns, and in department you will have department number, which is the primary key, and department name. Okay, and in project you will have the USN. Okay, the name of the USN of the student, and the project number and the project name. Okay, so you can see a single student information has been spanned across 3 tables. Okay, so let us take a scenario. Assume that there are 100 students. Okay, so belonging to 5 department: CS, IS, electronics, telecommunication, mechanical, something like that, and all 100 students are working on, say for example, 50 projects. Okay, assuming 2 students per project, something like that. Okay, so you can see 100 students information have been spanned across the 3 tables. Okay, so the example I have taken here is to prove that our DBMS is not at all suitable for processing huge amount of data. Let us understand why. Okay, so now how will you pull out all the student names and their respective department names and their respective project names? Okay, I want to write a query that will list out all the student names, their respective department names, and their respective project names. So what are we going to do? We are going to join all the 3 tables. Okay, so join operation is something that is very costly in our DBMS. Okay, so if you join these 3 tables, right, maximum of 100 into 5 into 50 rows will be generated. Okay, say 100 into 5 is 500, 500 into 50. Okay, so 100 into 5 into 50 rows will be generated. Okay, so which is 500 into 50, so which happens to be 25,000. So that becomes 25,000 records. You can imagine. So but the result will be only 100 students, but DBMS would have internally processed 25,000 records. Just to pull out 100 students data, DBMS internally have processed 25,000 records. Okay, this is the reason why we say our DBMS is suitable only for small amount of data. Okay, we don't prefer RDBMS for large amount of data, for big data. Okay, so that is why we speak about Hadoop. Okay, so now let me briefly walk you through what Hadoop is all about. Okay, you know that Hadoop is basically for processing big data, right? For understanding the working of Hadoop, I am going to give you a real-time scenario. Assume that you have to copy a file of 1 GB size into a laptop having 2 Mbps rate of transfer. Okay, so that means this laptop can copy 2 MB data in 1 second. So you have to calculate what will be the total time taken for copying 1 GB file. 1 GB file is nothing but 1000 MB, right? So for 2 MB it will take 1 second. For 100 MB it will take 50 seconds. So for 1000 MB it will take 500 seconds. Okay, so the calculation is very simple. This laptop will be taking 500 seconds for copying that 1 GB file. This is the problem. 500 seconds is too much. Okay, you have to reduce the total time taken. How will you do that? Okay, so let me explain the solution for you. Okay, the solution is what, rather than copying this file into one machine, okay, I am going to bring n such machines, something like this. Okay, I am going to bring 5 such laptops like this. Okay, and I am going to divide this 1000 MB file into 5 pieces. Okay, where each piece will be 200 MB, like this. And I am going to copy each part of that file, I mean each partition of that original file into a different laptop like this. Okay, so now if you calculate the speed of one laptop, if you calculate the time taken by one laptop, okay, this laptop will have to copy this 200 MB file, this laptop will have to copy this 200 MB file, like that. Okay, so for 1 second it will copy 2 MB. So for copying 200 MB it will require 100 seconds. Okay, this laptop will be requiring 100 seconds for copying that file. Okay, same 100 seconds will be taken by all the other laptops. Okay, what you people have to note down is all the laptops will be working parallelly because they are independent from each other. So overall time taken is just 100 seconds. Okay, so if you compare this time taken, originally we had 500 seconds, but now we reduce the time taken to 100 seconds, right? So this is the basic idea behind the working of Hadoop. Okay, so the solution is very simple. Rather than storing the entire data in one machine, divide that big data into small pieces and store them in multiple machines. Okay, so this is the basic principle behind working of Hadoop. Okay, so now to proceed further, I'll explain what actually meant by Hadoop. Okay, so before I go to Hadoop, you people are very well aware of MySQL. That means even you can take about Oracle. Okay, you know how MySQL database or Oracle database will work, right? Okay, basically MySQL database and Oracle database will be providing you two things. What are those? Capability for storing the data and capability for processing the data, right? So how actually MySQL will provide support for storing the data? All the data stored in your MySQL will be stored in your local machine. In the laptop where you have installed MySQL or Oracle, there only the data will be stored. Okay, how actually this MySQL and Oracle will provide support for processing the data? It will provide SQL query. Okay, so using this SQL query, you can process the data stored in MySQL, right? Same way. Okay, so Hadoop also the same thing. Okay, so if I speak about Hadoop, okay, Hadoop also will provide you capability for storing the data, and Hadoop also will provide the support for processing the data. Okay, so how actually Hadoop will provide support for storing the data? As you seen earlier, it will store the data not in a single machine. Okay, it will store the data in a distributed machine. Okay, it will store the data in multiple machines. Okay, so we call that as HDFS. Okay, full form for HDFS will be Hadoop distributed file system. Hadoop distributed file system, right? And how actually Hadoop will provide you support for processing the data through a programming model called MapReduce, through MapReduce program. Okay, so this is the comparison between your traditional RDBMS and Hadoop. Okay, so Hadoop will provide storage capability through HDFS, Hadoop distributed file system, and Hadoop will provide you processing capability through MapReduce program. Okay, that means if you have to retrieve the data stored in MySQL, you have to write an SQL query. If you want to retrieve the data stored in Hadoop, you have to write a MapReduce program. Okay, it's a very big program. Basically, you cannot write a one-line SQL query kind of thing. You have to write a very big program itself called MapReduce program. Okay, so this is the basic idea about Hadoop. So this diagram will summarize the working out of Hadoop. Okay, so if you can see the input data, Hadoop basically will contain basically two things, a name node and data node. Okay, so where name node will be only one in number, and there may be n number of data nodes. Okay, so you will understand in detail about what is name node and data node in the later classes, project classes actually. But as of now, what you need to understand in with respect to working of Hadoop, whenever you give an input file to Hadoop, it will be received by name node. Okay, and name node is the one which is going to divide this input file into small pieces. Okay, and each of those small pieces will be stored in data node. Okay, so what actually data node will contain? Data node will actually contain small pieces of input data. Okay, so because the input data will be distributed across multiple nodes, node is nothing but a machine. Okay, so because the input data is distributed across a multiple machines, we call it as a distributed file system, and this is provided by Hadoop. So we call this as HDFS, Hadoop distributed file system. Okay, so these are the few prerequisites that you need to know about Hadoop. You need to understand what is HDFS and what is MapReduce. So now let us understand the problem identification in this project. So here we will be stating the problem that we are supposed to solve in this project. So before we state the problem, so let us understand what you mean by file versioning system. So I'll give you a brief example for understanding file version system. So assume that I have written a text document called sample.txt and I am going to store it in Hadoop HDFS. So initially I will have the contents hello good morning. So inside sample.txt I will be writing the content hello good morning, and then I'm going to save it on Hadoop, and then I will open the file again in Hadoop, and then I am going to edit that file. So I'm going to edit that file to add a text called how are you. So after editing that, I'm going to save it again, and then once again I'm going to open that file, and then I'm going to add one more line called hope you are good, and then I'm going to save it. So it's like I have uploaded the file to Hadoop and I'm repeatedly editing that file again and again. So in this case I can say the first version of this file sample.txt, the first version of that file was having this content, and then the second version of the file had this content, and then the third version of the file had this content. So like that, a single file will be having numerous versions. When there we are going to edit it, so it will have each and every version to it. So this is what we call file version system. So now that you people are clear with what you mean by file versioning system, so now let us understand what is the problem identification in this project. So you can see, so the first problem is the file contents in the data storage platform like Hadoop could be contaminated by the bad data or viruses, resulting in errors during the course of data processing. That meant to say, if this is the original file, so some virus or some bad data might get added to the original file. So I need a mechanism to tell that this is not the original version of the file, this is the second version of the file. So I need some mechanism to find it out. So that's what this problem says. So that's what I have mentioned here. So there is a need for a way to examine and process the prior versions of the data files to identify the cause of the error. So that means given a file, so we should be having a way to find out all of its previous versions. Okay, so that if the file have been contaminated with some bad data, say for example if this is a bad data, so we will have a way to remove that bad data and get back the original version. So this is the problem in HDFS. So now let us understand the literature review of this particular project. So here we will be discussing about some of the existing solutions already available for solving the problem that we stated earlier. So we are not going to understand the detailed working of the existing system because our IEEE author have already proved that none of these existing systems can be used for solving it in an efficient way. So we are going to just mention out some of the research papers that are published for solving the problem that we stated, and we are going to mention their drawbacks. So first thing is we have a couple of papers published, so like I have mentioned here, and these couple of papers proposes an approach based on secondary name node. So in the basic prerequisites about Hadoop, you people have heard about name node, right? So same way there is another name node called secondary name node. So based on this secondary name node, they have come up with some particular solution. However, so the drawback of this particular solution is that the failure rate is very, very high. So that means the file versioning is not possible at all times. So it doesn't guarantee us the file versioning will be possible. So this is the drawback of these particular papers. And then there are two more papers that I have mentioned here, so which proposes some memory based schemes. So that means so they will be storing some versions of the files in a program memory or some permanent memory, something like that. So however, so there are some drawbacks of this particular approach as well. So it says it improves the performance of the file write and file read operations, but it doesn't provide the versioning of the files. So this memory based schemes will not once again guarantee the versioning of the files, but the performance of file write and file read operations will be improved a lot. So these are the drawbacks of these couple of papers. And then there are three more papers that are being published for solving this problem, and all these three papers speaks about snapshot based approach. So the snapshot based approach means saving the state of the machine somewhere, and when the user wants the original version of the file, so they are going to reload that state of the machine from where they have saved, something like that. So however, the drawback of this particular approach is that the snapshot is not at all possible when we have distributed machines. So that meant to say when in a true HDFS environment, so this particular solution will not be working because HDFS is always distributed, right? So this snapshot based approach will not be working efficiently in this distributed way. So and then there are some Dropbox, iCloud, sugarsync.com, so that you might have heard about, which will also provide file versioning. Okay, but this particular drawback is that so the local copies should always be present. So these solutions provides an approach for solving the problem based on the synchronization between local files and their duplicates on the cloud. So that means so the original files will be saved in locally, and all their versions will be saved somewhere in the cloud. So in this case, it's like we are introducing a dependency between the local copies. So it should always be available. So what if that local copies are lost, or some you have deleted by mistake or something like that? So this solution will not be applicable. Also, so when you have saved the local copies in one machine, you cannot retrieve that original file from another machine. So I can say this is not device independent. So these are the drawback of these particular papers. So now let us understand the proposed system along with its advantages. So we are not going to understand the implementation part in detail. So we are just going to understand what are we going to do in our project. How are we going to do in our project will be explained to you in the project classes. So we are going to propose a new design and implementation of an efficient scheme in HDFS to automatically maintain the prior versions of individual files using CVCS technique. So that means whatever files the user have uploaded, for each and every files the user is going to upload in HDFS, we are going to maintain the version information of it. So user can retrieve back the prior information of that file at any instance of time. So the advantage of our project is that the file versioning will be made available at any instance of files and any instance of time. So few existing system add this drawback, right? The file versioning might not be possible sometimes, but our project will be overcoming that, and we will make sure our file versioning is possible at any point of time and on any particular file. So this is the first advantage. And the second one is we will not be having any dependencies on local copies, and it is going to be device independent. So this is actually the advantage which the Dropbox or iCloud or something like that doesn't have. So they are dependent on some local copies and they are device dependent, right? So we are going to overcome the drawback and make our solution device independent, and there will be no dependency on any local copies. And obviously there will be no significant negative impact on file read and file write operations. So because we are maintaining the versioning information of every file uploaded to HDFS, so few people might think it will have an adverse effect on the upload time and the download time, but we will make sure there will be no impact on that. So now coming to the hardware requirement, so we will be requiring a machine with a minimum 2.4 GHz processor, and most importantly the virtualization should be supported by that machine. So because we need to install Hadoop, right? Hadoop cannot be installed on Windows. We need a Linux operating system for that. So rather than installing the Linux operating system, we will use a virtual box. So virtualization should be enabled on that machine. And we will be requiring at least 8 GB of RAM, because virtual box will take a lot of memory. So we will be requiring 8 GB of RAM, and 40 GB of hard disk is enough, and obviously a keyboard, mouse, a display device, USB interface, power adapter, etc. So coming to the software part, we will be requiring Windows operating system, on top of which we will be installing Linux VirtualBox. So it's like we will be working on both the operating system. So in coming to the programming languages, in the back end we will be using the Java, Advanced Java, J2EE, and Model View Controller Framework. So in the front end we will be making use of HTML, CSS, JavaScript, Ajax, jQuery, and Twitter Bootstrap framework. So for developing the project we will be using Eclipse, integrated development environment, and for deploying our project we will be making use of Apache Tomcat, and for database, for storing the user information we will be making use of MySQL. So these are the software requirements. I hope you have understood this project. So explain this project to your colleges like the way I have explained to you. So if they ask you any questions on this project, so feel free to send all those questions to me on this email ID. So I will be replying you back with the answers. So if you want the answers right away, please call me on 97420240666. I will be answering right away. So after I answer to your questions, you can go back to your colleges and answer them.